Hello, everyone. Welcome back to Mr. McGurk's Calc BC classroom, sort of. Today we learn how to take some derivatives. Um, I always hesitate to know how fast to go through this section because I know you've seen all this stuff, but I also think some of it's pretty important. So bear with me if I go a little slower than I might normally. But these are some basic rules for derivatives. We got a whole chapter's worth of them basically, but these are kind of the basic ones today. For right now, all our rules come from the definition. Like only rule, if I said right now, pretend you didn't know anything from last year, and I said find the derivative of x cubed, your only option would be to use the definition if you didn't have other ways. So everything that we do here is built on the definition and then builds on each other. Like once you know a rule, you can get other rules. So these are all going to be reviewed. The first rule has a name. It's called the constant rule. It's not a really big deal. It just says if y is equal to some number, then the derivative is zero. It's really easy to think about why. I'm going to try to tell you some whys today. If you have a function that's a constant like y equals 2, remember derivative is slope of tangent. The slope of that tangent line is always 0, right? You could also use the definition to figure that out also really quickly. So that's the constant rule. If someone says, what's the derivative of 3? You say it's 0. Okay. The second one is probably the first big rule you learn. It's called the power rule. Again, the names are not important, but I'm going to refer to the name, so it's useful for you if you know that. The power rule says if y is equal to x to some power, that the derivative is equal to that power n times x to the n minus 1. In other words, we like to say if you started with like x to the fourth, you drop the power, so the power comes in front. So it's 4x to the third. I'm actually going to prove this for you right now. Bear with me. Just for positive numbers for the power, but it works for any number, right? So if the power is 1/2, if the power is x to the 1/2, then the derivative is 1/2 x to the negative 1/2. You just subtract 1. I'm going to scroll down here and we're going to prove that. And what way we're going to prove it is by using the definition. So remember, my function is x to the n. I'm going to go through this pretty quickly. Hopefully you can follow it. So the definition would say limit as h approaches 0 of f of x plus h minus f of x all over h. So I'm just going to use that definition. So we're going to go limit as h approaches 0 of, remember, f of x plus h would be x plus h in for the x, right? So x plus h to the n minus f of x, which is x to the n, all over h. So now we have a limit problem like we did back in the first chapter. And you actually had a couple limits that look like this in the first chapter. So what we're going to do here is we're just going to expand, multiply it out, see what happens. So again, this is a little bit quick. This is the binomial theorem. Back in Algebra 2, you learn how to expand x plus or a plus b to any power. So I'm going to kind of expand that out. Hopefully you remember this. The first term's actually going to be x to the n. The next term's actually going to be n, whatever that power is, times x to the n minus 1 times h. All right. The next term in the binomial theorem, it uses probability and combination. So you may or may not remember this, but the next term is really not going to matter. I'll show you in a second. But the next term is actually n choose 2, which is combinations. Not a big deal if you don't remember that, don't worry. X to the n minus 2h squared. And if I expand this out, it's going to go dot, dot, dot. I have all these terms. It just depends on what that power is. And the last term is going to be h to the n. So that's that whole polynomial expanded out. And then you subtract x to the n all over h. Watch this now. It happens pretty quickly. X to the n minus x to the n. Okay, those are gone. And now what we're going to do is we're going to factor out the h. Limit is h per se. I'm going to take notice that every one of these terms here has an h in it, right? So we're going to go h, and we're left with n times x to the n minus 1 plus n choose 2, x to the n minus 2h. There's only one h now, and this last one is going to dot, 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 h to the n minus 1. it's going to turn out what's going to happen is those h's are going to cancel. All of these terms, no matter what they are always going to be 0 because I'm going to plug in that 0 for h. So they're all 0. And so I'm left with n times x to the n minus 1. Power rule. All righty. You don't have to know that proof. It's kind of cool, kind of interesting. If you want to dig a little more deeper, let me know. I'll be happy to help you. The next one is just a constant rule. So if you have a constant in front of a function, you can just take that constant out and then take the derivative of the function. So in other words, now if I go back 4x cubed, I can just ignore the 4 for a second, drop the 3. So it's going to be 3x squared or 12x squared. So in essence, the constant kind of just gets ignored, gets factored out, and then you can take the derivative. Probably what you would have done anyway, but it is definitely a rule. You could prove that pretty easily. Next one we just call the sum and difference rules. They're kind of useless, but we have to have rules in math. Useless is probably not the right term, but a lot of times things are really obvious to people, and so we just do them, but they need to be rule-based in case we use them later. But basically, a sum of difference just says that if you had a problem like x cubed plus x squared, you could just take the derivative of x cubed, take the derivative of x squared, add them together, you have the derivative of the whole thing. So if this is your y prime would be 3x squared plus 2x. This minus sign, same thing. You probably would have done that anyway, right? It does not work for subtraction does not work for multiplication and division, no. You can't just divide one, divide the other, but addition and subtraction, it does. So that brings us to what do we do when we're multiplied together? So that brings us to the product rule and the quotient rule. These get a little more complicated. I'll do a couple examples of both at the end here, but I'll just give you the theorems first. So if you have a product, f times g, you can't just take the derivative of f and multiply it by the derivative of g. It doesn't work that way. And it's easy to show on a slope. It just doesn't work that way. And it's easy to show using the definition. I'm not going to prove these two. They're pretty easy. I don't know if you remember this or not. Maybe I'll give you a second to see if you remember it. See if you can write it down yourself. Maybe pause the video for a second. I think it's always good to try. Pause over for me. The product rule is if you have f times g, it's f prime. This is how I like to say it. Derivative of the first times the second term plus the derivative of the second term times the first term. And I'll do example in just a second at the end there. So that's the product rule. Derivative of the first times the second plus the derivative of the second times the first. And then we have a quotient rule. Oops. Where you have f over g. G can't be 0, otherwise we'd have all sorts of problems. The derivative of that is a little more complicated. And these, by the way, just come from the definition. Okay, if you use the definition, you can prove this. But since you had this last year, I don't want to go through all those proofs. So the quotient rule says it's the derivative of the first times the second. Kind of starts like the product rule, yeah, derivative of the first times the second. But now it's a minus the derivative of the second times the first, all over, I'm sorry, I shouldn't say second and first. I should say top and bottom, numerator and denominator. So we go back, sorry. Derivative of the top times the bottom. Derivative of the numerator times the denominator. Top and bottom, numerator and denominator. Derivative of the bottom times the top, all over the bottom squared. So I will do two examples here in just a second, but before I do that, I got one last thing to do, and that's just to give you some notation. This is notation for higher order derivatives, second derivative, third derivative, fourth derivative, so on. So y double prime is the most common one. We just use 2 primes. You might see it derivative of y prime. So that's derivative of y prime. You might see d dx times dy dx are all different. This is another really important one, or this one. So we go d squared y over dx squared, or f double prime. Typically just y double prime, f double prime. Those are the big ones. If we have 3 derivatives, we put 3 dashes. 4, we go 4. Okay. So just real quick, I'll do really simple ones just so you can see an example. If you are comfortable with this, turn off the video, move along, do some homework. But just give you 2 quick examples. So like if I have Oops. If I have 3x squared times, I don't know, x plus x squared. So clearly I could multiply that out and just use power rules, but I'm going to show you the product rule. It's the derivative of the first term, which is 6x, times the second term, plus the derivative of the second term, which is 1, the derivative of x is 1, plus 2x times the first term. I'm going to make a suggestion to you that you don't need to simplify any of these answers. Just leave an answer like that, move on to the next problem, okay? And then let's just do the same problem as a quotient. And now take the derivative of that. So it's the derivative of the top, which is 6x times the bottom, x plus x squared, minus the derivative of the bottom, which is 1 plus 2x times the top, all over the bottom squared. And again, two things on these, all right? Don't change the original form of the problem because it's important that you know how to use the quotient rule, product rule, whatever it's set up to be. And then don't simplify at the end. That's just a lot of extra work. If you're like me, a little bit lazy, extra work, no good. I know it won't maybe match the answer in the back of the book because it'll be not simplified, but I don't expect simplification of these problems at all. I'll bring this up in class again tomorrow. In case you missed this, just go on to the next problem. So those are the basic rules for derivative. Hope you have some success on the homework. Let me know. If not, and you need some help,